As we continue our study of complex numbers, we've learned what a complex number is. We learned what an imaginary number was before that. Then we added, subtracted, and multiplied. And the next phase here is going to be dividing complex numbers. Our objectives here are we're going to figure out or write the conjugate of a complex number, which we've done conjugates of irrational numbers before, and it's going to be similar to that. And then we're going to divide complex numbers, and that's going to be similar to what we did when we worked with some of our irrational numbers also, when we couldn't have a square root in the denominator. And so that's what we're going to end up learning today to add to our knowledge of complex numbers. So in the math community, it's not proper, and we've talked about this before, to have radicals in the denominator. I is the square root of -1, so it's a radical, so I should not be left in the denominator of a fraction. In this lesson, we'll learn to divide complex numbers, which we call it dividing, but it's really simplifying it, which is writing it so there is not an I in the denominator. So we've talked about the word conjugate before. We see it here again. We talked about it with irrational numbers, and now it's going to be similar as we talk about it with complex numbers. So we see here that the conjugate of the complex number a plus bi is a minus bi. And that also can be written in another way. So we could think of it the other way around. Maybe we have the conjugate of a minus bi. Here's a minus bi. Well, what's the conjugate? It would be a plus bi. So they are conjugates of each other. And we're going to use conjugates. We're going to actually investigate this a little bit about conjugates, and then we'll use those in dividing. So multiply the following conjugates, which we learned how to multiply imaginary numbers. Then make a conjecture about the product of conjugates. So let's multiply these. These should look familiar to us. This is almost like an a plus b times a minus b. I'll multiply it out this time, but maybe next one we'll use that, what we've learned before, what this will be equal to. So we have 2 times 2, that's 4. 2 times negative 3i is negative 6i. 3i times 2, positive 6i. And then 3i times negative 3i is negative 9i squared. Looking at these two, that just becomes 0. Over here, we remember that I squared is equal to negative 1. So we actually just have 9 times negative 1, so 4 plus 9, which is 13. So we multiplied the conjugates together, and we ended up with 13. Just plain old 13. Over here, let's think of what we learned before with multiplying in the form a minus b times a plus b. That's going to be the first thing squared. And it's because these like if we look back over here at this example before, these two become 0. So we have 5 squared minus the second part squared, which is 4i squared. Well, we see I squared again. I squared is equal to negative 1. And so really we have 25 plus 4, which is equal to 29. So here we multiplied conjugates and we just got 29. Next one, let's use what we've learned before. We know the middle, well, let's multiply it out. So we got an a times a is a squared. A times negative bi is negative, I'll put it in alphabetical order, abi. And then here we have plus abi. And then our last terms there, bi times negative bi is negative b squared, I squared. We have exact opposites here, so they are going to be 0. So we have a squared. And let's take a look at this. We see a negative, or an I squared, or I almost said negative 1 because we're so used to seeing I squared and realizing that's negative 1. So we have a squared Negative b squared times negative 1 is going to be plus b squared. So this is really a general form. We didn't put specific numbers in here. We just took one complex number and multiplied it by its conjugate. And we ended up with a squared plus b squared. So remember, we're supposed to be looking at our answers and maybe coming up with some conjectures. So here we multiplied two complex conjugates, got 13. Two complex conjugates got 29. Complex conjugates, we got a squared plus b squared. I'll give you a hint. There's something missing that you might have thought might be in each of the answers, but it is not there. Not that it's missing because we missed it, but it works its way out of there. So 3i times negative 3i, these are conjugates. If you want to think through this, we could think, well, we have 0 plus 3i times 0 minus 3i. So they are conjugates, and that one's pretty easy. That's 3 times negative 3 is negative 9, and then we have I squared. Oh, but we have I squared again. That's just equal to negative 1, so we have negative 9 times negative 1, which is 9. So did you come up with a conjecture? When we multiplied conjugates, complex numbers, did we have I in any of our answers? No, we didn't. All of our answers ended up being real numbers. And so that's the nice thing about conjugates, which happened similarly when we did irrational numbers. If you multiplied conjugates, you didn't any longer have an irrational number. So here we multiply conjugates and we no longer have a complex number. We have a real number, and that's what we're going to use, because what I mentioned earlier is we don't want imaginary numbers in a denominator, and so we can use the conjugate to help us with that. So dividing complex numbers, you see what you can do here. Up here at the top, I jumped the gun a little bit in starting that first example, but to divide complex numbers, multiply the numerator and the denominator by the conjugate of the denominator and simplify, because when we multiply by the conjugate of the denominator, that denominator will no longer have an imaginary number in it. So we have 3. I'm going to write this as a fraction rather than how it's written there. And so we're dividing. We're going to multiply top and bottom by the conjugate. Well, the conjugate of positive 2i is negative 2i, so we're going to multiply top and bottom by 2i. In the numerator, we get 2i times 3 is 6i, minus 2i times 4i is 8i squared. And we have I squared again. Keeps showing up and showing up and showing up. Multiplying the denominator 2i. I did not put the conjugate, so actually I have to erase this and start over. Because I don't have to erase it. Let's just go back and change it. I didn't multiply by the conjugate. I just multiplied by 2i. Which actually in this case would work, but we don't want to throw ourselves off. We multiply by negative 2i. That would make this, so I'm going to change this. 2i times 3 would be negative 6i. 2i times negative 4 would be positive 8i squared. And then in the denominator we have negative 4i squared. Negative 4i squared. We have a few I squareds, which we know are negative 1. And so what we have here, we have our real number over here, which this is a positive 8 times a negative 1, so we have negative 8. Again, I'm going to put the real part first, negative 8. And then minus 6i over negative 4 times negative 1, which is 4. Actually, I still don't like this as an answer because this can be reduced. If you notice, 2 is a factor of each of these. So we can, since it's a factor of each part, and both parts of the numerator have a 2 in it, we can reduce by 2, reduce each term by 2. So that goes in there, 4, and then 3. So really our best answer, our reduced answer, is negative 4 minus 3i over 2. So we multiply top and bottom by the conjugate of the denominator. Over here we can rewrite this as a fraction. Same idea, we're going to multiply top and bottom by the conjugate. Conjugate of positive 6i is negative 6i, root 6i. Glad I caught the mistake early. And now we're going to multiply. (42) times root 6i is, and that's a negative, so negative 42 root 6i. And then negative times a negative, this is going to be positive 30 root 6i squared. In our denominator, we have a negative root 6 times a positive root 6. So multiplying square roots, that's just going to give us negative 6i squared. Negative 6i squared. Simplifying this, we got a few I squareds. That's a negative 1. This is a negative 1. And so we're going to put our real part first. So we're going to put this first. We have, it's a negative 1 times that, so negative 30 root 6. And then the imaginary part, minus 42 root 6i divided by a negative 6 times a negative 1 is 6. This actually also can be reduced. These can all be reduced by 6. Not inside the square root, but outside. Each of these is a factor of 6, so 6 goes into this once. 6 goes into that, we'll put negative 5 and negative 7. And so our answer, we're squeezing in our answer here. We're going to have to adjust some things. But we got negative 5 root 6 minus 7 root 6i. And so that's our answer there for that second one. I'm going to go ahead and, now that we have this, I'm going to delete this work so we can actually see or have enough room. So let's just delete all of this. Still didn't get it all. And we're going to do this last one. In fact, I'm going to just rewrite it over here to give us plenty of room. So we have 3 plus I divided by 2 minus I. I failed to mention something in the first two. This one is where it's probably the most helpful because it makes things easier. If we look back, and I should have mentioned this before and I didn't, that was one of the important things of this last slide. As you look at each one of these examples, we had a 2 and a 3, 2 plus 3i, and a 2 minus 3i. Notice we ended up with a 2 squared, this 4. This 4 came from 2 squared, and this 9 came from 3 squared. So we really just ended up with 2 squared plus 3 squared. So that's interesting. That's something we actually should have noticed before, I should have mentioned before. Here we have a 5 minus 2i and a 5 plus 2i. We ended up with a 25. Well, that was 5 squared plus 2 squared. 5 squared plus 2 squared. It's really obvious here that we ended up with an a squared plus b squared. And here we ended up with 9. And again, the ones that are just an imaginary part aren't as, we can figure that out pretty easily. But please notice this one right here. When we multiply complex numbers, complex conjugates, a plus bi times a minus bi, our answer will always, always, always be the first part squared, a squared, plus b squared. That will really simplify things as we get to this last problem here. So multiplying a number times its conjugate will be a squared plus b squared. Wrong one. So I'm going to multiply by a conjugate of the denominator, 2 minus I, sorry, the conjugate is 2 plus I, over 2 plus I. While it's fresh in our minds, I'm going to go ahead and we're going to do that, what we just said right away. When we multiply complex conjugates, it's going to be a squared, which is our 2. So in the denominator, we're going to have a 2 squared, plus b squared, which in this case is 1. Then we don't even have to multiply it out. It's going to be a squared plus b squared. In the top, we do have to multiply. No shortcut there. So we have 6 plus 3i plus 2i. And we have another I squared, so plus I squared. So I'm going to change this I squared to a negative 1. And then we're going to go ahead and simplify this in the numerator. We have a 6 minus a 1 as our real part. 6 minus 1 is 5. Plus 5i. In the denominator, we have 2 squared, which is 4 plus 1, which is 5. Notice again, we can simplify this. 5 goes into each one part once in this case. Whoops, that's supposed to be a 1. And so our denominator is 1, so we can just write 1 plus I. So the answer to that one was just 1 plus I. And again, we did see that nice important thing where multiply a number, a complex number times its conjugate, it's just a squared plus b squared. And we simplified to just get 1 plus I. The last part is kind of just an application of this. Find the reciprocal of 7i. So the reciprocal of 7i, we know what reciprocals are. It's 1 over 7i. But there's a problem with this. We have an I in the denominator, so we're going to multiply top and bottom by the conjugate, which is negative 7i. So in the numerator, we have negative 7i. In the denominator, we have negative 49i squared. We know that I squared, for about the 20th time, is negative 1. And so we end up with negative 7i over 49, which can reduce by 7. So we have negative I over 7. So our reciprocal of 7i is negative I over 7. And our last one here, our reciprocal of 1 over 3 minus 6i. Well, we can't have an I in the denominator, so we're going to multiply the top and bottom by the conjugate, which is 3 plus 6i. Again, that thing that we learned earlier, that we multiply complex number by its conjugate, it's just going to be equal to a squared plus b squared. In the numerator, that's nice and easy. It's just 3 plus 6i. In the denominator, we have a squared, which was 3, plus b squared, which was our 6. 3 plus 6i over 9. 3 squared is 9 plus 36. 9 plus 36 is 45. We can do some reducing again. 3 goes into all of these. 3 goes into this 15 times. 3 goes into this once, and 3 goes into this twice. And so the reciprocal of 3 minus 6i, reciprocal of 3 minus 6i is 1 plus 2i over 15. Doesn't look much like the reciprocal, but that is the reciprocal written in the proper way. of 3 minus 6i. That was a longer video. Hopefully you caught those different things with multiplying or with dividing. Again, our objectives were to write the conjugate, so we should be able to easily come up with the conjugate of a number, and then divide complex numbers. And to divide complex numbers, really what we did is we multiplied the numerator and denominator by the conjugate and then simplified from there.